Now let's consider the modulus function and its properties. Now, if I am writing modulus of fx, when does the definition of this function change? See, the definition of this function will changes when fx equals to 0 or when fx is negative. Otherwise, there is no such change in the definition of modulus of fx. Now, if the graph of fx is given, then we can draw the graph of mod fx. So, by just taking mirror image of the part of fx which is below x-axis over the x-axis. I'll repeat it once again. If the graph of fx is given, then the graph of mod fx can be obtained by taking mirror image of the part of fx which is below x-axis over the x-axis. For example, if I take fx equal to sin x. Now sin x has got a graph like this. See, this kind of graph is followed by sin x. Now, these are the points minus 2 pi, minus pi, 0, pi, and then 2 pi. Now, if I want to draw the graph of modulus of sin x, now all I have to do is, I have to mark which part of sin x is negative. So, sin x is negative in between minus pi to 0 and from pi to 2 pi. So what you got to do is you take the reflection of this part over the x-axis and this part over the x-axis. So if I want to draw now mod sin x, it should look like this. See, this is how the graph of mod sin x looks like. Minus 2 pi, minus pi, 0, then pi, and then from pi to 2 pi it should be here. So for drawing the graph of mod of fx, always remember what you have to do is take mirror image of the part of fx below x-axis over the x-axis. I'll take another example also. If I want to draw mod log x, then this is how the graph of log x looks like. This is the point 0 to 1 where it is negative. So what you have to do is, you take the reflection of this part over the x-axis. So reflection of this part, you will get something like this. So that means I'll be drawing here. So 0 to 1, it is going to be like this. And from 1 onwards, the original graph of log x is going to be retained. So just this is what you will follow, a simple technique for drawing the graph of mod fx. Now let's draw the graph of f of mod x. Now mod x is always greater than equal to 0. Now mod x is greater than equal to 0. So for drawing f of mod x, you need to consider the graph of fx which is valid only on the right side of x-axis. सिर्फ x-axis के दाहिने पार्ट में जो fx का ग्राफ होगा उसका मिरर इमेज y-axis के अबाउट बना देना है. क्यों? कोई भी एक पर्टिकुलर वैल्यू f of mod x, f of in fact alpha, is going to give you the same value as f of minus alpha. Why? Modulus of alpha is equal to plus minus alpha. So that means for two equal and opposite values of x, you should get the same value of the function. Now, I'll again parallelly compare it. Now first, I'm drawing the graph of sin x again. See, this is how the graph of sin x looks like. 0, pi, 2 pi. Here you have minus pi, minus 2 pi. Now, if I take the reflection, now 0 to pi and then pi to 2 pi. See, this graph of sine x is going to be followed. So 0, pi, 2 pi, 3 pi, like this. Now, this is the part of sine x which is valid for x greater than 0. Now, take the mirror image, just rotate this graph 180 degrees in this manner. So, you get a graph like this. So, this is how the graph of sine of mod x will look like. Now, let's take another example. So, now, once again have a careful look. See what I have done in f of mod x. See, I have considered the graph of sine x valid for x greater than 0. That is the right side of x-axis. I have retained that part. And I have taken the mirror image of this part about y-axis. So for drawing f of mod x, now you have to consider this aspect. All you have to do is forget the left side of the graph. That is, forget the part of the graph which is valid on the left side of x-axis. Just leave the part which remains on the right side. Take the mirror image of this part on the left side, and this complete graph will give you the graph of f of mod x. Now, let us take few more examples. Now, if I am drawing e to the power, say, mod x or minus mod x, I want to draw this graph. See, e to the power minus x has got a graph like this. Now, which part of this graph is valid for the right side of x-axis? See this part. Now, this point is 0, 1. So, forget this part now. And take reflection of this part about y-axis. So, this remaining part, now this gives you the part of e to the power minus mod x. Similarly, if I want to draw, say, log mod x. Now, how do you draw it? See, log x has got a graph like this. See, this kind of graph is followed by log x. Now, this graph exists only for x greater than 0. So, there is no part on the left side as such. So, if there is no part as such on the left side, all you have to do is just draw its reflection. So, this complete graph signifies the graph of log mod x. Now, how do you draw the graph of f of minus mod x? Now, for drawing the graph of f of minus mod x, now you should consider the function's graph valid on the left hand side of x-axis. Now, let me explain this with an example. See, again I will take the example of sine x. So, sine x has got a graph like this. So, this kind of graph is valid for sine x. Now, forget the part of sine x which is on the right side of x-axis. So, if you forget this on the right side, you are left with only this much. So, first you draw the left hand side part of this graph. Now, take the mirror image of this part about y-axis. So, if I take the mirror image of this part, see, it looks like this. So, this is the graph of sine of minus mod x. Now, as you can see, for drawing f of minus mod x, what you need to do is, you need to consider only the part of the function which is valid on the left hand side of x-axis. Now, forget the part which is on the right side. Take mirror image of the remaining part about y-axis and you get the graph of f of minus mod x. Now, if I ask you the graph of mod y equal to fx. Now, how do you draw the graph of mod y equal to fx? See, mod y equal to fx. Now, first analyze the left hand side. See, left hand side is always greater than or equal to 0. So, the right hand side should also be greater than or equal to 0. So, that means we need to consider only that part of fx which is strictly above x-axis or it touches x-axis. Now, from here I will also say y is equal to plus or minus fx. That means since you are getting two different values of y corresponding to a single value of x, so this is not a function, but still it is a relation and its graph needs to be drawn. Now let me give the example of say mod y equal to sin x. I want to draw this. For drawing this, again draw the graph of sin x itself. Now I am drawing the graph just over a limited cycle. Say this is minus 2 pi, this is minus pi, this is 0, pi, 2 pi. Now, forget the part of this graph which is below the x-axis. So, we will remove this part, we will remove this part. Now, you are left with these two parts which are above the x-axis. So, let's get to this. So this is how the graph of mod y equal to fx will look like. Now the question is, why I am teaching you all this? See, these things will help you solve questions in a much faster and much efficient way. Now let me take a couple of examples. Now if I have a function, let us consider fx equal to minus 1. For x lying between minus 2 and 0, and for x greater than 0 less than equal to 2, I am writing x minus 1. I ask you, find gx equal to f of mod x plus modulus of fx. If I ask you, find this. Now, how do you calculate? See, no doubt we can proceed by the analytical way, but let's proceed by the geometrical way. So first, let's start by drawing fx. See, if this is your fx, it is constant at minus 1 from the interval minus 2 to 0. Now from 0 to 2, it follows y equal to x minus 1. So this is your x minus 1, it cuts the x-axis at the point 1. This is your x-axis, this is your y-axis. So if this is my graph of fx, how will f of mod x look like? Now, as I told you, for drawing f of mod x, all you need to do is forget the left hand side. So I am left with the right side. And this is the graph, that is x minus 1. Now take reflection of this part about y-axis. So this will be now minus 2. This will be minus 1. The slope of this line is 1. So the reflection will have a slope minus x minus 1. Now what about mod fx? Now mod fx, you will take the reflection of minus 1 here. So it will be like this. And what about the reflection of this part? The reflection of x minus 1 will be here, minus of x minus 1, that is 1 minus x. So that means the graph of mod fx, if I draw, it is going to be 1 here, then it is 1 minus x, and then it is the original, that is x minus 1. So clearly you can see the two things. Now from minus 2 to 0, see this is equal to 1 and this is equal to minus x minus 1. So now I can add the 2. So minus x minus 1 plus 1 gives you minus x, provided x lies between minus 2 and 0. Now for x lying between 0 and 1, x minus 1 plus 1 minus x gives you how much? 0. For x greater than equal to 1, less than equal to 2. See, x minus 1 plus x minus 1, both of them combined gives you 2x minus 2. So this is a faster geometrical way of getting the definition of gx. let's take another example. If I ask you, okay, find the number of solutions. Find number of solutions of, say, modulus of mod x minus 5 is equal to 7 to the power mod x equal to 3. Now, this is an equation which is quite difficult to be solved if I solve it analytically. So, what you should do is, first you write it like this. This is equal to 3 into 7 to the power minus mod x. Now, we should solve these kind of cases always geometrically, never analytically. So, let's proceed to draw the graph of mod x minus 5. If I take fx to be x minus 5 whole mod, see, this is the kind of graph, V-shaped graph, as I told you, it should look like. Now, tell me, if I replace, if this is your fx, the left hand side is what? F of mod x. So, how do I draw f of mod x? Take this part on the right side. So, I am just retaining this part on the right side. And now I will draw the reflection of this part on the left hand side. So, this point will be how much? 0, 5. This point will be 5, 0. This point will be minus 5, 0. So, this is how the graph of left hand side looks like. Now, drawing 3 into 7 to the power minus x first. See, 3 into 7 to the power minus x will form a graph like this, where this will be your 0, 3. So, if this is your 0, 3, now forget this part which is on the left hand side. Now, in order to get the graph of 3 into 7 to the power minus mod x, take mirror image of this part. Now, this is how it will look like. So, 0, 3 is a point here. So, if 0, 3 I am drawing, see, it will look something like this. Now, tell me how many intersections do the two graphs have? See, here you have one intersection, here you have one intersection, here you have one intersection, here another. So, एक चीज आप लोग mark करो, graphical method, we are getting the answer very fast. We can see that this equation has 4 solutions. So, if this has got 4 solutions, now if we try to solve this analytically, then definitely it would have been much more longer. Now, let us take one more example. Now, find the number of solutions of, suppose I am writing the equation as log mod x with respect to base half is 2 times of mod x. Now, one is a logarithmic function, the other one is a simple modulus function. So, log mod x, let's first draw this graph. Now, log x with respect to base half, it forms like this. Now, if I want to draw log mod x, I have taken mirror image of this part. This point will be minus 1, this point will be 1. Now, mod x has got the typical V-shaped graph starting from origin. So, 2 times of mod x, that means it will be slightly steeper, that is, इसका slope increase कर जाएगा. अब ये दो graphs कितने points पे intersect कर रहे हैं? Clearly you can see 2 intersections. That means number of solutions यहाँ पे कितना है? The number of solutions is equal to 2. See, hardly I think if you try to solve these kind of questions using this method, you can solve it within 10 seconds. At the most 10 to 15 seconds. It won't take more time than this. Now, let us consider another example. Find the solutions, if I ask you, is solve for mod x 2 minus mod x is equal to y and mod y plus x is equal to 1. Now, this is a case, if normally I try to solve this, then naturally I'll say that it is an equation involving 4 simultaneous equation pairs. Now, instead of solving it that way, now let us solve it analytically. See, y equal to 2 minus x will be a straight line like this. Y equal to 2 minus x. Now, instead of x here, you are having what? Mod x. So, this point is 0, 2. Forget this part now. Now, draw the reflection of this. So, this complete graph, inverted V shape. Now, this gives you the graph of y equal to 2 minus mod x. Now, drawing mod y is equal to 1 minus x. 1 minus x has got a graph like this. Which part of this graph is valid? Which part of this graph is above the x-axis? See, this part. So you forget this part. And you take the reflection of this part about x-axis. So now, x-axis, now I'll plot this graph over this graph. See, this line is y is the original equation, 1 minus x. Here I have taken the reflection, so it will be y equal to 2 plus x. Now if I draw both of them simultaneously, see, it is like this. Now these two are never going to intersect. Now these two will never intersect, but see, this and this, they are intersecting. So y equal to 1 minus x and 2 plus x. So now you solve them, 2 plus x. So 2x is minus 1, so x equal to minus half. If you put minus half here, y is equal to 3 by 2. So you can see this equation has only one solution.